Hi everyone, welcome back to Data Cadence. My name is Rahul. I work as a senior applied research scientist, and in this video we are going to talk about how to deal with outliers in a data science or machine learning project. This is also an important interview question since the interviewer might try to test your grasp and your depth of knowledge in statistics and basic data processing. So it's important to understand some of these techniques on how you could deal effectively with the outliers. So outliers are data points that differ significantly from other observations in your data and can have a profound impact on your model's performance in a real world scenario. And in a realistic setting, you will encounter outliers pretty frequently, whether be it due to measurement of errors or data entry mistakes or genuine variability in your data. Understanding how to handle these outliers is crucial for building robust and reliable models. So in this video, we will delve deeply into the various techniques that we use for dealing with outliers, ensuring that you are well prepared to tackle this common challenge in your next data science interview or project. So without further ado, let's begin. I would also like to mention that dealing with outliers is separate from identification of outliers. So I will probably have another video in which we talk about what are some of the various techniques that we use for identifying the outliers in the first place. And in this video also we'll try to go as deep as possible, covering all the basic as well as the advanced techniques that you need to know. So without further ado, let's begin. The first technique is yes, to simply discard the outliers. So you can simply remove the data points that are identified as outliers. And this is the most simplest approach and a no-brainer, and it directly eliminates the influence of outliers, but it also reduces the dataset size, right? So this is a valid answer, but probably not what the interviewer is looking for. And as a smart data scientist, you have got to know some more techniques that you can try before simply removing and throwing out your outliers from the data. So the second one could be to apply some sort of transformations, and some of the common and most famous transformations are the log transforms. So you can simply take the logarithm of your particular feature value where you have identified the outliers, and this will be effective when the data is right skewed, and it essentially compresses the range of your values, therefore reducing the impact of extreme values, right? The other types of transformation could be a square root or a cube root transformation, right? So these are suitable for moderately skewed data, and these are similar to the log transformations but are relatively lesser aggressive, right? The third one could be clipping. Again, it's pretty intuitive. So in clipping, you can basically set a predefined threshold values, and the values above this threshold values are set to the threshold value. That is, you can essentially clip your outlier values to the particular threshold value, and the effect that it has is it directly limits the extreme values to a fixed boundary, right? The one question that you might ask is, how do I set this particular threshold value? So you can use a technique like z-score to basically find the optimal threshold for your clipping process. The fourth one is similar to clipping, is a technique called Winsorization. So the idea here is to basically limit your extreme values by capping them to a certain percentile, say the 99th percentile or the first percentile, for example. And to achieve it is very simple. You determine the lower and the upper percentile, say for example the first and the 99th percentile, and you simply replace the values below the lower percentile with the value at the lower percentile, and for the values which are above the upper percentile, you simply replace them with the values at the upper percentile. The effect that it has is reduces the particular influence of some of the extreme values while retaining them in your data set, right? So there is no loss of data involved when you're doing clipping or Winsorization. And like I mentioned, Winsorization is pretty similar to clipping. The only difference is in clipping, you have a predefined threshold value. In Winsorization, you are using percentiles as that particular threshold value. Rest everything remains the same. Let's talk about the fifth technique, that is imputation. So here again, you can use a mean or median based imputation, that is, you simply replace your outlier values with the mean or median of that particular feature. The effect that it would have is it would smooth out your data by reducing the variance that is caused by the outliers. But the drawback is that you are only considering that particular feature in isolation, and you are not considering the impact or the relationship and interaction of the other features. And that's where you can use the imputation using a model. So what you can do is you can train a very simple model to predict the feature values based on other features. This model could be a simple k nearest neighbors or any other simplistic model. And then you can use this particular model to predict and replace these outliers, right? The effect that it would have is, and the advantage is that it considers and leverages the relationships and interactions with the other features to provide a more informed replacement of your outliers. Let us talk about the sixth approach, that is to utilize the algorithms that are more robust to outliers. So here, for example, you can use algorithms like tree-based methods such as random forest and gradient boosted decision trees, essentially techniques like bagging and boosting. So they can naturally handle the outliers due to their hierarchical structure and split-based decisions to a great extent. And let's talk about how does bagging and boosting take care of the outliers. So in bagging, the core idea is to create multiple subsets of your data through sampling with replacement, also known as bootstrapping. And then you train separate models on each of these subsets of data that you have created. And at the end, you try to aggregate all of these predictions together. This aggregation could be a simple mean or median based aggregation for things like regression, and a simple majority vote for a classification use case, right? The effect that it would have is it would reduce the variance and can handle outliers better by averaging the predictions. So since you are aggregating all the predictions at the end, the impact of outliers is reduced to a great extent, right? And that's how bagging can take care of your outliers. When we talk about boosting, the core idea is to sequentially train the models, each model correcting the errors of the previous ones. And the effect that it has is it can be more robust to outliers by focusing on harder to predict cases in a very controlled manner. And you can also use certain algorithms with robust loss functions. So you might be aware about L1 and L2 loss. So Hoover loss is the loss function that combines the benefits of both L1 and L2, bringing out the best of both the worlds. And it is less sensitive to outliers compared to a squared loss. So you can also use a loss function like a Hoover loss to basically take care of the outliers. The next thing that you can do is, of course, to use regularization. So you might be aware about L1 and L2, that is lasso and ridge regularization. And the idea is to add a penalty term to your loss function. And in L1 loss, you add the L1 norm of your weights along with a regularization coefficient called lambda, that is the L1 loss, and it encourages sparsity in your data. The L2 loss, you basically take the L2 norm and it penalizes the large coefficients. The effect that the regularization will have is that it will shrink the coefficients of less important features, and therefore it will reduce the impact of your outliers. Let's talk about the last technique, that is the isolation forest. So isolation forest is more of an outlier detection technique rather than an outlier handling technique. But the core idea is that you randomly select a feature and split a value within that feature's range. And you recursively do this particular partition in the data until all the points are isolated. And the last thing that you do is you calculate the average path length to isolate each of the observations. And the effect is that the outliers, which are few and different in number, will have relatively shorter paths and are identified more easily. So isolation forest is one of the most popular techniques for identification of your outlier data points. So in this video, we saw a lot of techniques, right from the beginner level techniques to the advanced level techniques, and how you can deal with the outliers in an effective manner. And I believe that I will prepare another video for how do you detect or identify the outliers in the first place. So I shall look forward to that, and hopefully that will help you understand like how do you basically identify these outliers, right? I hope that this particular video helped you gain some insights into this particular topic of handling outliers. And I will basically request you to like this particular video if it helped you in any particular way, and also subscribe to this channel for more such content around interview prep and data science in general. So see you in the next video then. Until then, take care. Bye bye and keep learning.